At Data Futurology, we love creating events that can help you overcome the challenges that you're facing in your work, in your organizations right now. So I wanted to quickly tell you about a free webinar around accelerating MLOps. This is on the 26th of July at 11 a.m. We're going to be sitting with Romina Sharifpour from AWS, and she's going to tell us about how carsales.com.au was able to use their SageMaker platform to improve the creation, deployment, and operationalization of their machine learning models. So come join us for that really exciting webinar. For more details, please check datafuturology.com/events. Thanks so much. Hope to see you there.
I'd like to say a big thank you to our sponsors, Talent Insights. Talent Insights are Australia's leading specialist data recruitment business. With offices in Sydney, Melbourne, and Brisbane, they're experts at providing recruitment strategy and building data teams for clients across industries Australia-wide. They provide recruitment solutions for all roles across the data lifecycle, including data engineering, data science, advanced analytics, customer and marketing insights, business intelligence, data product managers, and data governance. They're skilled at finding the best permanent and contract hires for your business needs, as well as statement of work, project focus, data resources. At Talent Insights, relationships matter most. I can say from first-hand experience, Talent Insights are fantastic to work with. Whether you're a business leader within an HR network or a specialist data candidate, Talent Insights should be the first company you turn to for all your data recruitment needs. Find them at talentinsights.com.au.
Hi, this is Felipe Flores from Data Futurology. Today, I have a very, very special guest for us. It's Melanie Johnston-Hollitt. I'm so excited to get to pick your brain. Melanie, how are you going today?
I'm fantastic, Felipe. How are you?
Yeah, so good, so good. I wanted to start by asking you to give us a little bit about or an overview about your background, and then tell us about the type of things that you're passionate about and thinking about at the moment.
Sure. So at the moment, I'm director of the Curtin Institute For Computation, which is a data science institute, and I'm also director of the Australian Space Data Analysis Facility, which is a facility which helps SMEs and researchers look at space data. But my actual personal background is in astrophysics. So I'm a professor of astrophysics by training, and I spent 20 years working on international, large-scale, big data radio astronomy projects. So I've come into data science through a slightly circuitous route.
I love it. So good. And what I was going to say before is that I'm originally from Chile, and I grew up in the north of Chile, which is in the Atacama Desert, so the driest desert in the world, which has like heaps and heaps of telescopes. At one point, very large telescope, which is very exciting. That I remember going to visit it when I was like in high school. So, and I remember hearing about the number of petabytes that they're getting from the telescopes, and having to sort of whittle that data down to find ways to then be able to manage it. So I think there's so much overlap between the two fields, and it's really exciting.
Yeah, so first of all, I'm jealous that you've been to the Atacama telescope facilities, because they're large optical telescopes, and the optical astronomy community would argue that they're producing a huge amount of data, but it's nothing in comparison to what we do in radio astronomy. So absolutely. One of the cool things about the telescopes they have in Atacama is they do an enormous amount of data generation from system modeling. So they're constantly collecting data on the status of the telescope system in addition to the astronomical data itself. And the data that they collect on the actual telescope system is as much as the astronomical observation data. So they've got a huge amount of information on the instrument. But even so, in radio astronomy, we produce ridiculous amounts of data. So the next generation radio telescope, which is called the Square Kilometre Array, which is just to start construction at the moment in Western Australia and South Africa, is going to produce in combined 160 terabytes of data per second, raw data. So yeah, it's huge. So the low frequency component does 157 terabytes per second. The other one, which is a dish array. Yeah, it's mad. So how you deal with that data of that size and magnitude and turn it into knowledge rather than just storing data for the sake of storing it is a really interesting problem.
Exactly.
Yeah. So when you say what drives me and what I'm passionate about, I'm really interested in how you extract knowledge out of different data sets for different purposes and the barriers to do that, which are often not technological, but actually human factors. They're human barriers.
Yes.
So that's what I'm interested in.
Yes, so true that it's often the change management, the aligning of incentives, the convincing and the getting momentum is so often like the biggest barrier in technology adoption and progress of innovation in organizations. So is that something that you see a lot as well?
Yeah. So what I find is people internalize messages and they don't really realize why they're internalizing them. And then 20 years down their career, that becomes a barrier to technology adoption. So I'll give you an example in the field of radio astronomy. So when I was a PhD student 20 years ago doing my thesis on radio telescopes in Australia, we were using, big dishes. They were very heavy. You had to drive them and point them at whatever you want to point out in the sky. And so the expensive part of the data chain was collecting the data. So you don't want to recollect the data. Storing the data was relatively cheap. And so my PhD supervisor said to me, data are precious. We've got to keep every piece of data. You've got to put it all in an archive because you don't want to go back and reobserve. That's the expensive part. And so anyone who's a radio astronomer of my generation who are now managers globally have internalized this message, but not understood that it was an economic driver. So now when we're looking at this huge telescope, the square kilometre array, where you're getting, 157 terabytes of data per second, there's this internalized view of humans that you should keep all the data. But the expensive part for that particular telescope, because it's not driven by mechanical steering, it's driven by electronic steering, so timing basically, so it's fixed, and then we just correlate the signals depending on where we want to collect data from the sky. Observing is really cheap. Running the telescope is cheap. Storing that amount of data is extremely expensive.
Wow.
And so, but you run into this situation where rather than say, okay, well, can we throw the data away? You've got this internalized reaction to say, no, we should keep it all. Yeah. And that doesn't really make any sense. If the objects that you're observing change on the timescale of millions of years, you're actually better off taking the data, processing it as quickly as possible, throwing it away, and then reobserving. So effectively, you're using the sky as your archive. And as long as the timescale of the objects you're observing is longer than the archive, reprocessing time, so how long are you going to go back and reobserve, that's fine. Yeah. But you cannot, it's hard to get people to think about it that way because they've internalized this view that data are precious. So it's really interesting to run into those type of situations.
So interesting, where rules of thumb like catch us out as the technology landscape evolves under our feet. And I think it's something that everyone has those heuristics that they leverage on often, and sometimes in times where they shouldn't. And I know that definitely happens with me. Like I've this year I've been like on a bit of a crusade to understand what are some rules that I had for myself, professional rules that then are now no longer valid, and it's interesting uncovering those, but you're seeing that at a systems level, which is even more interesting and challenging.
Yeah, it's really, really difficult. And the other thing, of course, is that we've had, for example, the ability to work remotely for 20 years. Like when I went to university as an undergraduate, I was told, knowledge workers are going to be distributed across the world. And that didn't happen, not because we didn't have the technology, but because managers didn't trust that if you didn't put everybody together in a room and they could go and knock on their door, that they would actually be productive. Whereas productivity is a mindset. Productivity is about, the willingness to do the work and being supplied with the tools that you need. And if you're going to be lazy in your workplace, it doesn't matter if you're on the job or remote. That's an unproductive worker. It's not about location. And it was only that COVID came and forced that change, right? An external force came in and removed that human barrier, that human fear that allowed us to actually work as remotely as we are now, even though we've had that technology for 20 years. So yeah, absolutely. You see this at system levels and also at individual levels. And it's a really interesting question to sort of be able to how do you convince at the system level a whole bunch of people to do what you're doing and review their own biases and heuristics? So yeah, it's a fascinating field.
So interesting. Yes. And I think there's often improvements in productivity that get stuck in that same pattern as well, that it's kind of like, this is the way that it's always been done and we should continue to do that. A simple one that comes to at least to my mind, probably too often or surprisingly often, is keyboard layouts. And the fact that we have this layout that was trying to separate the letters that were most often used together, or that in the words are quite close together, and those letters wanted to be separated in the keyboard, and that's a keyboard layout that we have now, and that there are additional or other alternatives where it's faster to type and easier for people to do that, and there's that barrier of adoption because we're accustomed to doing things the way that it's been done, even though there's new generations coming in that haven't seen what was there when that layout was designed. At one point, AI will be the way that we interface with computers, and then keyboards will be a thing of the past. But I think until then, we're stuck with the layout that we have.
Yeah, it's funny, these legacy things that kind of just perpetuate. I am aware of the first women computers in astronomy, which happened in the 1890s in Harvard. And these were women whose job it was by eye to examine optical plates and actually note down in a ledger where the interesting objects were to be found and their coordinates. And they were then trying to do analytics on those things to sort of improve our understanding of the life cycle of stars and stellar classification. So these are first data scientists.
Yeah.
And what I find amazing is my first job in astronomy, which was again nearly 20 years ago, it was exactly that. I was given a project at the Anglo-Australian Observatory where I was told to take a hand lens and scan optical plates to look for planetary nebula. And at the time, I was like, surely I can't be doing the work that was being done 100 years ago. But in fact, I was. And to my great embarrassment in some senses, I actually gave people a similar project only 4 years ago. And that was because we had automated some of the detection processes, but some of that stuff's still really hard. And the easiest way to do it is to still have humans do it. And so there's a difference, I think, between the work that humans still have to do because we haven't developed technology that can do some of those hard things. So if you're looking for an object which is really bright and sits above the noise in your image, a computer can do that, like an AI can do that. If you're looking for something which is fuzzy or requires you to apply external context, a human brain is still the way to do that. But that's very different to what we're talking about here, which is where you run into this thing that somebody says, oh, it always has to be this way, and I don't want my job to change and lose my job. And that's human fear rather than anything which is constructive. And so that barrier, I think comes up again and again and again.
Definitely. And what are some ways that you started to use on a recurring basis to identify that and then start to provide it some structure? Because when it's a heuristic that sometimes people are not conscious of, it's to help bring out the awareness, you almost have to create some structure for them, or do you? What's your process like?
I do two things. So the first thing is I usually ask people why. So in the case of my peers who've internalized this view that data are precious and not realize that that's an economic argument that was valid 20 years ago and isn't valid now, potentially, I ask them why they think it's the case. And I try and get them to sort of step back and look at the entire system and to realize that was an economic thing and to think about whether or not they can overcome that heuristic. The other thing that I try and do with people is I talk about what their job is holistically and how AI and machine learning can take away the drudgery parts of it, and that their job isn't going to go away, but it's going to evolve for the better. So we have a good example at the moment. We're currently working on a fish counting algorithm in the Curtin Institute for Computation. So the way that fish ecologists understand the health of marine reefs is that they put baited stereoscopic cameras under the water. So the fish come, they collect the video, and then an ecologist sits there and counts the fish by hand. And yeah, we spend $1.4 million a year in this country on highly trained fish ecologists eyeballing videos of fish. And when you do that, that's important work for them to understand the ecology of reefs and so forth, because the more fish species you have is a great indicator of the health of your reef. But it takes such a long time for humans to do that, if you've got sensitive areas in threat in the marine environment, you've got a 6-month delay between collecting the data and getting an outcome. And so, but that's a small part of what a fish ecologist does. Right. So what we've done is we've developed an algorithm with machine learning that will actually do that automatically in real time and take that drudgery away. So you talk to people about how what we're helping them do is shorten the path to what their goal is. So whatever their goal is, machine learning and technology should help you with that, not necessarily take your job away, but change it for the better. So that's the other process.
I love it. Yes, that's great. I always think that, as humans, we are, in our jobs, we're problem solvers. And the job is there to solve a problem.
Yeah.
And technology is unlikely to solve the whole problem, or if it does, then we can move on to higher level problems. But the job, in my view, the job is there to solve a problem.
Yep.
And the problem will continue to exist in different levels. So the faster that we can solve the problem, the better. And that's why, technology and AI should be embraced quickly for that progress to come. Sorry?
Absolutely. So I was just going to say, I think there's 3 things that will hopefully happen. So 1, some of the drudgery will go away from jobs, but people will be able to do that higher level stuff. 2, you'll be able to augment people's ability to do their job. So if you think about medical AI that sits alongside a clinician and provides them with possible explanations for the symptoms that they're seeing, it doesn't take away the experience of the medical professionals or the clinicians to make a diagnosis, but it draws on the experience of a huge range of people that a single person can't have. Because what we don't want is, we don't want to be limited by what you can learn in your lifetime and you can put in your brain. I had a really good example of this in my personal life. I had a situation where I had a very rare problem with one of my eyes. So it's an autoimmune condition where your own body decides that your iris isn't part of you and attacks it. But it's not that common. And I was traveling around the world at the time, and I went into a hospital in France, and they misdiagnosed me. And that resulted in me having some permanent scarring on my cornea. Doesn't matter, it's outside of my field of vision, so it's not a disaster. But it was uncommon. And the doctors I was seeing, even though they were in the ophthalmology department of the hospital in Nice, hadn't seen it, and so they misdiagnosed it. The next time it flared up, I happened to be in Urumqi in rural China, so in northwest China. Or Urumqi is a big city, but it's a remote part of China. The doctor there, because the Chinese population is so large, knew what it was immediately. Even though I was dealing with him through a translator, he understood. And that was because of just the volume of people that he'd seen in his lifetime. So what you want, though, is you want that clinician back in France to have AI have a record of all of the medical databases, so that next time somebody like me comes in, they'll be able to suggest that as a possibility and not send me away with a misdiagnosis. So that's an example of kind of augmenting people's careers for better outcomes for them and for patients and everyone, and not being limited by human brains. And I think the third thing that I like to think about in terms of the future of work at AI is the creation of new types of jobs that utilize humans in ways that we haven't been able to do before. So as you know, AI and machine learning is only as good as the data you put into it, and that has to be validated. And I think there's going to be a creation of roles for humans to do validation, and that work can be done by people who are remotely distributed, who are perhaps older and still wanting to be in the workforce. And so there's a real opportunity there to leverage the fact that we've got an aging workforce and still let them do productive work wherever they are, which I think is really exciting. So those are the 3 sort of things that I think about when I think about the evolution of work and the adoption of technology.
Outstanding. Because I totally agree. Like on your second point, it's about lifting the standard, in this case of care, but the standard that the work is done, and making that higher standard available for everyone to be able to consume, keeping the human in the loop, as you say, I think continues to be critical. And on your third point, I think that the the capturing of human knowledge in data is going to be critical, I think, over the next decade, to be able to create better AI and AI that reflects or helps us create the world that we want to create, because the problems that we've had is that by taking the data that we have, that data was captured in a world that might have had that has some biases, that isn't necessarily the historical view of the world isn't necessarily the world that we want going forward, but the world was like that. It's captured in the data. If we feed that data to the algorithms are going to perpetuate that. The way to fix it is by essentially better labeling the data, and that, in a lot of fields, that requires really expert knowledge and working alongside with AI to say the AI says, hey, I have a bad prediction or a high error rate for this data point. The human reviews it and goes, hey, actually, that you got some mislabels here. Let me fix it up. Throw it back into the model, and this is an iterative process of capturing more of the knowledge worker experience, and also help us create the world that we want going forward with these machines.
Yeah, 100% agree with you. I think we're going to see the rise, as I said, of data validators. Some of them are going to be specialist data validators for a particular industry, and some of them are just going to be particularly for image-based stuff, just people who can see, that's a chihuahua and not a blueberry muffin, which, as you know, is difficult for machines right now.
I love that example. That's great. And in that space, there's a lot of things that need to improve that. In the sense, what I mean by that is, in the times that I've had projects that needed a lot of labeling of data, I sort of thought, great, I can make some guidelines and farm it out to a lot of people. I might have examples that I get labeled by multiple people, and then try to see if they align, and if not, kind of like escalate. But I think the mindset that I had that was my original incoming assumption, and then the mindset that I had to develop throughout is that it's an iterative process. That I was creating guidelines that I thought, like, obviously being biased, I thought they were clear and great. And then I found that I was getting lots of labels that were different, and they were all following these guidelines. And I'm like, well, shit, I got to improve my guidelines so that we have more consistent labels. And I think it's important to, anyway, go in with that mindset that it is an iterative piece of work, and it's so important for us going forward to have that data.
I totally agree with that. One of the things that I think is an outcome of that, which people are not really aware of, is how much time you should build into your workflow and pipelines exactly to do that iterative process to get a good outcome. So I didn't do this work, but I'm aware from astronomy that the optical astronomy community had a citizen science project where they wanted to classify things as either spiral galaxies or elliptical galaxies. So just two categories. And then they had an other. And for astronomers, that's really simple. That's not a difficult thing. But it turned out when they distributed this to huge numbers of people in the general public, they had to refine their guidelines again and again and again. And what they discovered was they needed every object to be looked at by 20 different people to be able to be sure that the classification would be what an astronomer gave. And that process took many years longer than they thought it would. And so I 100% agree with you, but I think it's a thing that people who are working on AI projects that need that data validation piece need to factor into the timelines of their projects.
Yes. And then a hurdle there is, how do you develop consensus from different opinions?
Yeah.
Have you seen anything, any good ways to do that?
I think that then comes back to working with the experts in the field. Yeah. So certainly for astronomy, on the few projects that I've seen, we've gone out to citizen science. We've got stuff which is not consensus, but we've got a triage process where something which comes in from the general public and has a variety of different views gets flagged to be reviewed by an expert, rather than just drive from the community consensus. So that's probably the best example. And I think anytime you put humans together, you probably have difficulty getting 100% consensus. And then you really have to look at what your business outcomes are or your research outcomes, and then pick some rules and heuristics based on where you want to get to. But that, I think, is also an interesting field. How do you get humans to agree to things? And in straightforward things like, is this a chihuahua or a blueberry muffin? Easy. In things where you've got ethical components, that's really difficult. And so ethics around AI and setting up heuristics for AI ethics, I think, is a really, really challenging field. And actually, I was talking to somebody about this morning in detail, and I don't have good thoughts on that myself, because that is really difficult. So I'm really interested to see how that develops as well.
It is. It is so difficult. I'm in the same boat as you. Like, I don't know. I don't know enough. I'm super interested, and I think it's going to be evolving along with societal views, and we have to keep questioning it and need to stay on top of it. Because there's some really interesting examples. Like one of them was the Apple credit card, which is obviously a famous one that they released with Goldman Sachs, where one of the Apple co-founders, Steve Wozniak, got a credit limit 10 times higher than his wife. They said it's discrimination. Then the Department of Justice, they did an inquiry into it, and they decided that it was not discrimination. And it was because they said, in this case, the husband was the breadwinner, so he should have a higher limit. And then it's like, well, should he? Like, is that the world that we want? And I think these are the type of conversations that AI is helping us, almost forcing us to have, which are so important, so critical for us.
Well, the other thing associated with that is that the legal system is slow to move. And so we are in the regime where the laws that we have and legislation is often falling behind what the technology is able to do. And so there's a real impetus, I think, for legislators to have a better understanding of what technology can do and what technology is already out there. A recent case that was alerted to me was facial recognition capture. So, so there are, your face print is actually a piece of your personal data, which is potentially very valuable. Like my bank uses it to open my app on my phone to be able to access my bank records. But when you go into particular stores like Bunnings, for example, they do have a notice that says they're capturing those kind of images. What are the privacy implications of that? The legislation doesn't say. And so those are things which also need to evolve alongside our adoption of technology, and perhaps a little bit faster than they currently are. So, fascinating stuff.
100%. Yeah. So interesting. So interesting. No, I love it. And what type of projects have you guys been working on or deploying where you're seeing, well, if you can tell us, I was going to ask whether you're seeing slower than expected adoption in some of those, and then how do your three areas apply to these?
It's a really interesting question. I think probably the most frustrating thing in the field of data science is where a client will come in, they'll have a brief where they want something to be done, and we will help them sort of shorten their process pipeline using AI or machine learning. The part of the business that we'll be dealing with is really happy with that, and then they take it back into corporate, and corporate goes no for regulatory reasons or human reasons. I'm trying to think of examples I can actually talk about.
Like in the meantime, like I'll tell you one around lack of adoption where so I work in healthcare, using AI for healthcare, and we have a client where we were getting data for people that were going to the hospital, and we would score them on how much benefit it would be to their health and to this company's financials, how beneficial it would be to give them additional support after their procedure. And And then we would send these, the data that we got was all anonymized, de-identified. So it was just on the clinical outcomes, essentially, clinical information.
Yep.
And then we would send that back to the customer to say, here's the ranked list of people every day. And they would call them up and offer them that extra support that was for free for them. And we started this, more than 2 years ago. And about a year into it, I found out that they were not using the ranking at all.
Wow.
And just calling people at random. And I was like, well, why? And they're like, oh, just our systems can't handle it.
Yeah, that's so frustrating.
And like from then, it took a year to get the change.
Yeah.
The people on board, the change management, to get the technology changes to the features, to the auto dialer, etc. Another year for the calls to be ranked and for people that will get better health outcomes from the support for them to be called multiple times. And I was like, this should not have taken 2 years to get there.
Well, I mean, you work in the health field, so you know that in addition to the human factors of change and adoption, you've also got these privacy and regulatory things. And one of the frustrations for us in working with healthcare data is that it's siloed, and you can't necessarily, for good reasons in many cases, take data out of a silo. So we have to send our data scientists outside of our facility into the healthcare facilities to work directly with the data. So they're trying to sort of develop models on our systems, which they don't have they have to use dummy data, and then they have to go in and use the facilities on site, which are often not set up and often require a lot of permissions. So we get sort of a bottleneck there, and then we find out that they can't adopt our ML systems, or AI. So yes, so you'll do a project. We did an amazing project on a stillbirth risk register.
Oh wow!
And that, as far as I know, has not been implemented, even though we did that work 2 or 3 years ago. So wow. There's so many things we could have.
Exactly.
But we don't, because of these human factors. So either the legislation's not in place, or people are unwilling to go through the change process in the organization to do something that can, cause a change, or people don't want to learn new stuff. I mean, I see this barrier all the time is, plasticity of humans decreases as we age, so of our brains. And so where young people are really interested in adopting new technologies and so forth, older people are not. And so when you're dealing with an older workforce, they really don't want a new piece of software or a new process even. And so I think that also is a slow process. So you can have these things be created, but then just adoption stalls. And that's a human factor. That's a biological human factor.
Correct. Yeah. And like, I've noticed myself like getting like too frustrated when like I'm not getting software to work the way that I want, and I'm like I shouldn't be this frustrated. Like, not that I'm like, I don't know, I'm not kicking a door down or anything like that, but for the scale of the problem, I was way too frustrated relative to that, and I'm like, oh, I'm getting old. I need to work on this.
Yeah, it's a funny thing. So I myself have this thing where I don't really want to learn how to reprocess astronomy data, radio astronomy data, which I notionally an expert in. But we've got new software now. I'll still go back and use the old software to reduce the data, although at least I will use new processes. I was going to say, one of the really frustrating examples for me of technology not being imported into a workflow was I worked very closely with one of my former students for many years on new algorithm design for processing radio astronomy data. And we found that there'd been an error in the way that we'd processed a particular type of data globally for 40 years.
Wow.
And so all the results in the literature were not necessarily wrong, but they were only valid on high signal to noise. Whereas if you fix this, you could go down and do stuff on low signal to noise. So this opens up a really interesting field. And the correction was really, really simple. It was 3 lines of code that needed to be changed in most of our processing packages. And I think I got it changed in about 2 out of the 10 or so different processing packages. And despite the fact that we had new telescopes coming on board for which they were writing the new software, and I was going to these people and saying, look, this is wrong. Can you implement this particular process? It didn't happen. So we've built new instruments, multi-million-dollar instruments, that are still using a process which is known to be wrong, because that was easier to take this legacy software and to just adapt it. And that is probably personally the most frustrating example for me. So
for sure. Oh, that is
only 3 lines. That is 3 lines of code that need to be changed.
And the impact is massive.
And the impact, yeah. So instead of having to be, we had all these sort of weird things in the literature said you had to have a signal to noise above 7 for the results to be valid. Well, you can drop it down to 3, the standard 3, if you do what you should do, and it's still not done. So,
No. Oh, that is very, very tough.
Yep, and we did that work in 2016. So, yeah.
No. And so what? I guess what do you make of all these examples, and what do you recommend as a way forward, or things that people can implement?
So I think from my perspective now, it's really important to touch base with the human side of these things. So even if people are coming from the technology perspective, you need to have an understanding of the humans that are going to be using the technology and are going to be benefiting from the technology, because those 2 things are what creates these barriers. And so what I would like to see is when data scientists start to work on processes with clients and so forth, we don't just ask the technology questions. We don't just ask, what's the scope of the project? What are you trying to achieve, et cetera. From a process point of view, we ask the questions, who's going to use this? Can we talk to them? What are their experiences? What are their limitations? Because I don't think there's any point in spending effort on creating new solutions and new technologies which are then not uptaken. So I think that's probably the best advice that I can give. And so we've tried to start to do that recently, where I've tried to kind of go, well, how can we make sure this actually gets into production? What extra steps in this project does the client need to think about in order to have that uptake? And what extra steps do we need to put in to make it easier for you to adopt? And the other thing that I've been asked to do in the last 18 months is to talk to executives about data science and machine learning and AI and how they can transform business, and to allow them to understand that it has to be a whole of operations process. There's no point doing a small piece and then discovering that the people who run your operations processes are not interested in uptaking new technologies. And so I think those 2 things allow organizations from the top down to get an overview of where they need to put resources across the whole process, rather than see it in little siloed pieces, and to allow the data scientists themselves to start asking those other questions of how can I make this easy?
I love it. Those are excellent tips. Just the other day, somebody was asking me like what kind of like what I wish executives knew about data science, and like it's this, like it's exactly this.
Yes, I think if we can talk to executives more so that they know this stuff, any organization that wants to let technologists and data scientists talk to their executives, big thumbs up. Please do that. It's good for you. It's good for us. Helps the world change.
Exactly. I love it. Thank you so much. I think that is a wonderful note to end on. Bring in the human element earlier. And when you're from an exec perspective, deploying AI is a whole of business endeavor, not a localized AI department efforts. So, Melanie, I want to thank you so much for sharing, some of your knowledge, experience, your insights. They are absolutely fantastic. So thank you so much for taking the time with us today.
Oh, thank you, Felipe, for the invitation and the fantastic conversation. It's been fantastic and my great pleasure.
So kind. Thanks for watching this video all the way to the end. I hope that you got a lot out of this discussion. And if you're watching on YouTube, please like and subscribe to the channel so more people can find out about the challenges that leaders have in the analytics and AI space. And that's what we're trying to share in Data Futurology. So please like and subscribe. And if you enjoyed today's episode, please tell your friends. Thank you so much.